Hello, welcome back to Chapter 8, Section 6, Radical Expressions and Rational Exponents. If you need a break, pause and go take a break because this video is going to be probably a little bit longer. There's 8 problems from this section that I need to do, and I'm going to be talking about each of them. So, when we did this before in the second, if you're watching these videos in order, it would have been the second video, example number 2. I said that I want to take what's under the radical and I want to break it into powers that have that index as the exponent. All right? Sometimes that's going to be easy, like number 5 is going to be easier, sorry. Sometimes it's going to be a little difficult. Now, if I look at all the problems we're going to be doing, notice that number 6, number 7, number 10, and 11 and 12 have fractions. So I'm going to also have to be aware of rationalizing my denominators. But we'll get to that. Here's the main idea. I'm going to break this down with the main idea for number 5. We're going to make this easy, okay? 8 is 2 to the third power. Those are the same. And of course, x to the third power is x to the third power. So what this is 2 to the third power, which is 8, multiplied by x to the third power. Now I put a little space in there, pretend I didn't put any space in there. Because now I'm going to take the cube root of both parts. And whenever I have the cube root of something cubed, those are inverse operations of each other. So the cube root of 2 cubed is just 2. It's literally asking what number times itself equals 2 times 2 times 2. It's 2. That's what it means. And the cube root of x cubed is just x. So this is going to be 2x. All right, so you're going to see that with all of the other problems, except sometimes we're also going to have division. Now we're going to see what happens if I simplify and I still get a radical, because not everything's, sometimes I'm still going to have part of a radical. If I simplify and that still happens, then I'm going to have to rationalize it. Let's see what happens here. So I know that 32 is actually 2 to the 5th power. That doesn't help. Or maybe it does. 2 to the 5th power means 2 to the 4th power times another 2. How does that help? So 32 is going to be 2 to the 4th power times 2. And again, pause the video if you need to process that. Divided by x to the 4th power. Now I'm going to take the 4th root of each of these things. So the 4th root of 2 to the 4th power is just going to be 2. And unlike this time, I didn't give myself enough space here. This is the 4th root of 2. And of course, this is the 4th root of x to the 4th power. So this I can simplify. This just becomes 2. The 4th root of x to the 4th power is just x, which is nice because we don't know if x is irrational or anything, but we're just going to leave it x, okay? What about this one? Well, guess what? I just leave it. You don't need to try to convert it to a decimal or anything else, okay? Sometimes, now if this was 16, which is 2 to the 4th power, that'd be nice. I wouldn't have this extra part. So what this is actually saying, and think of it this way, okay? 32 is 2, actually, let me not use box. 2 times 2 times 2 times 2 times 2 to the 5th power. If I put these together, that's where I get the 4th root of 2 to the 4th power. So what goes in one of these boxes is 2, that one. But over here, what's the 4th root of 2 I have to do something different with that. So that's where the extra 2 comes from. All right, so we still got some fractions. Let's see what's going to happen here. 125, that's nice. That's 5 to the 3rd power. And I'm going to take the cube root of that. X to the 6th power is x to the 3rd power times x to the 3rd power. And I'm going to take the cube root of both of those. Put my dots in here to multiply. And the denominator, 6 is not a power of any whole number. So this is going to be the cube root of just 6. Okay, so I'm planning this. I'm not just working it out. I'm thinking about it while I'm doing this. Sorry, I get the hiccups. So I broke my factors into cubes as much as I could, just like I did here and just like I did here. I had something left over. I'm going to end up with something left over here. The cube root of 5 cubed is 5. The cube root of x cubed is x. The cube root of another x cubed is x. X times x equals x squared. Of course, you could have done the cube root of x to the 6th power and did 6 divided by 3 and got 2. That would have been okay. I don't know what to do with the cube root of 6 in the denominator. So I have to rationalize it. The cube root of 6 is irrational. That would be 6 to the 1/3 power, which you know now. And this is a decimal approximation of it. I don't want to deal with decimal approximations. What I want to do is I want to put a number in the denominator that is rational. It's not a decimal that goes forever. So I'm going to multiply by the number 1, just like I did earlier in chapter 8. But here's the deal. This is what I'm thinking, okay? I'm just writing what I'm thinking. I know that 6 times 6 is 36. But I don't know what the cube root of 36 is. But if I include another 6, 6 times 6 times 6, which happens to be 216, but that's really not important right now. If I take the cube root of all of this, each part, then this whole thing is going to be the cube root of 216, which equals 6. So here's the big thing. Oops, move that so you can see it. Here's the big thing that causes problems. We rationalized denominators earlier this year, and we will be doing it again when we get to trigonometry. But at that time, you just multiplied something by itself, like the square root of 5 times the square root of 5. Why did that work? Because it was the square root. I only needed 2 of them. This is the cube root. I need 3 of them. So this is what I have. That's right there. And I need this. So this is going to be the cube root of 36. 6 times 6 is 36. And when it's all finished, when I clean it all up, I get 5 times x squared times the cube root of 36 divided by just 6. And again, why is it just 6? Because multiply 6 times 36, get 216, and now I'm going to take that to the cube root, and I get back to 6. I get a rational number. So how many 6s do I have? 1, 2, 3. That has to be the same as what the index is there. So again, ask questions. Number 8, let's look for some perfect squares. 50 is not a perfect square because I'm doing a square root. 50 is not a perfect square, but 50 is going to be 25 times 2. And x to the 3rd power, that's not a perfect square, but that's going to be x squared times another x. So if I have 25 times 2 times x squared times x, that's 25 times 2, x squared times x. Take the square root of everything. The square root of 25 is 5. The square root of x squared is x. I move that to the front of the line. The square root of 2 is just the square root of 2. And the square root of x is, so far, x. Since x is a variable, I don't know what it is. So I was able to pull out perfect squares from what I had. I had 50. I know that that's a perfect square multiplied by another number. I can take the square root of that 25, that perfect square, and simplify that, but I don't know what the square root of 2 is. Okay, or at least I'm not going to estimate it. All right, like I said, this is going to be a longer one, so if you need to take a break, go for it. I'm already at 10 minutes. I'm only halfway done. Okay. So I've got the fourth root of x to the 8th power times the third root of x to the 4th power. These two indices, that's plural index, indices, are not the same. So I cannot put these together somehow and do 8 plus 4 and get 12. Okay? If these two were the same, if they were both 4th power, I could do that. Or both 3rd power, they could do it. But since they're different, I can't. So I'm going to break it into parts. X to the 8th power is x to the 4th power times x to the 4th power. 4 plus 4 equals 8. And when I take the 4th root of that, I'm going to get x times x. Now on this side, x to the 4th power is x to the 3rd power times another x. 3 plus 1 equals 4. But keep in mind, I'm doing the cube root. So this is going to be the cube root of x to the 3rd and the cube root of x. So it's nice because 8 divided by 4, that's 2. This is going to be x times x, which is x squared. That's good. But this one is a little tricky. I can take care of the 3 of them, but I get this 1 left over. So this is x times x times x, which is x to the 3rd power. And of course I don't know what this is, so I'm going to leave it cube root of x. Okay, seriously, pause this if you need to take a break, if you need to rethink that, because I'm gonna mention one thing here. Check this out. This is not in this section, but if I did cube, I'm just gonna come over here to the side. If I did this, here's another way of thinking about it. And again, my job is just to give you options, all right? We know, and this will be the next video, that's why I really shouldn't talk about it in this video, this is gonna be x to the 4/3. Well, usually we don't do this, but this is 1 and 1/3. Usually we don't convert to a mixed number. And the reason why is because people forget that 1 and 1/3 means 1 plus 1/3. So this is going to be x to the 1 plus 1/3, which is going to be x times x to the 1/3 power. That's my x right there. And the 1/3 power of x is my cube root of x. So there's two different ways of explaining it. Hopefully one way will make sense. But remember, you're learning the various skills with it. Okay, I don't want this to go too long. So I've got x to the 5th power. X to the 5th power is going to be x to the 3rd power. That's 3 of them. And I've only got 2 of them left. So I'm trying to split this into x's to the 3rd power. I only got one group of x times x times x, and then I got x squared left over. Okay? 4, well, 4 is 2 squared, but I don't have anything cubed. So that's not going to help. So I'm going to write this x to the 3rd power times x to the 2nd power divided by 4, and then I'm going to take the cube root of each of those. Now the only thing I can do to simplify here is this one right here. That's just x. and I would leave everything else alone, except I have to rationalize this. Okay, so what more do I need? So I'm saying that like something times something times something equals 4. So I need the other two. So I'm going to do cube root of 4 times 4, which is 4 to the second power, and the cube root of 4 to the second power. Now in the denominator, I've got 4 times 4 times 4, 3 of them, which equals 64, but that's okay. This is just going to be the cube root of 4 to the third power, which is just 4. Rational. In the numerator, it looks like a mess. Let's clean it up. I still have my x. These two have the same index. Like these two did not, but these two do. So now I can write cube root of, and I got to put the constant first as a coefficient, 16x squared. Should extend that a little bit more. As always, pause it if you don't understand. Number 11, now we're getting into some really tricky stuff, okay? We're going to break this. Notice that the radical in the numerator is a square root. This is a cube root in the denominator. Okay, what does that mean? The denominator might actually be easier to start. This is saying what number times itself again equals negative x cubed. All right? And one thing I mentioned about parentheses, radicals have implied or hidden parentheses. So I'm gonna, like I said, I'm gonna find the what number times itself again equals the whole thing, negative x cubed. All right? So here's what I know. I know a negative times a negative times a negative equals a negative. So it's going to be negative, and x times x times x equals x cubed. So this is just going to be negative x. I'm going to write that right here as actually. But let's talk about the square root of 40 x to the fourth power. Now let's think about 40. What is the largest perfect square that is a factor of 40? So 40 would be 2 times 20. Neither of those are perfect squares. 4 times 10, 4 is a perfect square. And 5 times 8, and 8 times 5, and also 1 times 40, but I'm trying to find the other factors. The only perfect square is going to be 4. So the square root of 40 is the square root of 4 times the square root of 10. X to the fourth power means x squared times x squared. So this will be the square root of x squared times the square root of the other x squared. And again, I don't know why I don't draw these big enough. So I took the 40x to the fourth and I broke it into perfect squares that I know of. That's 4, that's a perfect square, so that's just going to be 2. I'm going to save that one for the end. The square root of x squared and the square root of x squared are both x. X times x equals x to the second power. And by the way, you certainly can ask, excuse me, 4 divided by 2 does equal 2. So we remember that from the examples that we've already done. Now the reason why I put the square root of 10 over here is, like we said, a radical symbol, whatever this picture is, it's kind of open on the right. So we always move it over to the right side so that we don't put anything after it. Negative x is still there. And before I leave this problem and walk away from it, x squared divided by x equals 1x. And of course I've got a negative, so I'm going to end up with negative 2x square root of 10. Now I hesitated to actually say this, but in class a lot of students say, well, don't you have to do something with the square root of 10? And the answer is, well, what do you want me to do? They're like, well, don't you have to rationalize? I go, you're forgetting the second part of that. It's rationalize the denominator. That square root of 10 is in the numerator. It's fine. It's only when it's in the denominator, like this one's going to be, that I end up with a problem. All right, I know this one's a long one. I'm on the last one. I thought for a moment I'd lost a piece of paper. Okay, so I have x to the 12th power, which is x to the 4th times x to the 4th times x to the 4th. And then I have y to the 4th. And I'm going to take the 4th root of each of those. And those are nice, because that's going to be x times x times x times y. The denominator, though, is going to be the 4th root of 3. That's not so nice. So x times x times x is x cubed times y. The 4th root of 3, I don't know, but it's irrational, so I need to rationalize it. So again, think of it this way. Whatever the 4th root of 3 is, if I multiply it by itself 4 times, I end up with 3. Something times something times something times something equals 3. That's what I'm looking for. And you can probably tell this isn't going to be a easy number to think about. It's going to be irrational. What I have right here is this one. What I need, I have this one. I need these, the other 3. So I'm going to multiply by the 4th root of 3 to the 3rd power. So, and by the way, this is not 3 times 3 times 3 times 3. I know that gets a little confusing, but this is the 4th root of 3 times the 4th root of 3. You can also think of it this way. The 4th root of 3 to the 3rd power, like that. So the 4th root of 3 is that one, and then 1, 2, 3, 1, 2, 3, the 3 other ones go there. I think we get into this idea that, like, oh, I just want 3 times 3 times 3 times 3. If I simplify it, I get x, hopefully I got enough room here, to the 3rd power times y times the 4th root of 27. And then here, I've got the 4th root of 81, which is just 3. And then I have a rational number in the denominator. Okay. Yeah, 23 minutes long on that one. So hopefully you took a break in the middle of it. See you in the next video.